everyone, welcome to the session. So now in this particular video, we will talk about the recurrence relation of the ternary search that we have covered up in our previous part. Okay. So far we have discussed that in a ternary search, the major approach is to divide the search space into three halves. And then we are looking for that whichever element that we are looking for is either lying in the first part or the second part or the third part. Considering those things in our mind, now could you tell me that what should be the recurrence relation for this ternary search? So what is the recurrence relation for this ternary search? Now when we talk about this recurrence relation, obviously we are not forcing or we are not saying to the code to go in all the three directions. It will either move towards the first subpart, or it will move towards the second subpart, or it will move towards the third subpart. It means that the recurrence relation is equals to T of n, which is equals to T of n by 3, because we are dividing our search space into three halves, plus C, where C is the constant, which will take a constant time to just checking the if conditions, right? And returning the same. So majorly, this is the recurrence relation for a ternary search. Now, you can solve this recurrence relation with the help of various methods. For example, if I will try to show you using the substitution method. So what will happen? So you know that when the value of n is small, for example, if your search space is containing only the single element, at that point of time, can I say that it will take only the constant amount of effort? But when the value of n is greater than 1, at that point of time, this is the recurrence relation that we are getting, T of n by 3 plus C. By saying that when the value of n is equals to 1, it means that there is only single element present in an array. And at that point of time, we can just move a simple if condition that the element that a user is looking for is present in the array or not. That's it. So now, here what we can do is that we will try to substitute this value of T of n by 3. So if we will substitute, it will be equals to T of n, which is equals to T of n by 3 to the power 2, because we will again further divide it by 3 plus C, and above C will remain as it is, right? If you will do it further for the third time, again it will happen. It will be T of n by 3 to the power 3 plus 3 times C. 1 C is for this substitution part and 2 C's we are copying from here. So it means that if you will try to observe here that we are in each and every step while going below dividing the value by 3 by 3 by 3 by 3. Now the question comes that until what point of time we keep on repeating this task. So can I say that it will be n by 3 to the power k, and this value should be equals to 1, because what we want is that we want this value to be equals to 1. So when this will happen, so you can just solve this equation. It will be n by 3 to the power k, which is equals to 1. N is equals to 3 to the power k. So the value of k is equals to log of n base 3. This is the value of k that you are getting. It means that you need to repeat this step until k times. And when you repeat this step until k times, you will be able to get the value of T of n, which is equals to T of 1 plus, can I say it will be equals to C times log of n base 3, or I will not jump directly towards this step. Let me show you. So if we will repeat this until k times, it will be T of n by 3 to the power k plus C times k. How is that so? Because here if you will see, first time this is the equation. Second time it will be power 2 and 2 times C. Third time power 3, 3 times C. If I am saying I am repeating this as a same task k times, so power k, k times C. Now you can place this value of k as log of n base 3. So what I can say is that T of n by 3 to the power log of n base 3 plus C times log of n base 3. Now here what you can do is that you can take the value of n as upfront. So what will happen is that it will be T of n by n to the power log of 3 base 3 plus C times log of n base 3. Now here this will be equals to 1, this will be 1, and T of 1 is nothing but is a constant plus C times log of n base 3. So the overall time complexity that you are getting here is log of n base 3. Right? So this is the overall time complexity of a ternary search. So here we are specifically interested and we are talking about a ternary search only. Right? So this is the overall idea behind the recurrence relation followed by the time complexity of a ternary search. Now there is one question for you all. I'll not give the answer for that. I'm looking for your responses. The question is very simple. We have understood what is binary search. We have understood what is ternary search. You all know now what is the time complexity requirement for the binary search and for the ternary search as well. Specifically saying, order of log of n base 2 will be for the binary search. Order of log of n base 3 will be for the ternary search. Can you give me one simple explanation that which particular searching algorithm is the best one according to you? And why is that so? Don't write or don't say some random answers. Justification for that is pretty much important. So simple straightforward question says that if suppose an array is given to you, array is sorted also. What do you think? Whether we should divide our search space into 2 halves or into 3 halves. And here we are studying about ternary. We can have 4 halves as well, depending upon the requirement. What do you think should be the better way? Should we go towards binary or should we go towards ternary? Because these two things we have understood so far, right? In the next part of the video, you will see the implementation of this ternary search. It's quite simple because if you will know the concept, implementation is very easy. This is what I used to say at each and every time. But still, I'll try to show you. And with this, happy learning to all. Bye-bye everyone. See you soon in my next upcoming video.